Welcome to today's webinar on the design and construction of the Colombo Lotus Tower. Today's webinar is organized by Structural Design Institute in collaboration with Civil and Structural Engineering Consultants, more commonly known as CSE Consultants. To give you all a very short introduction to Structural Design Institute, we are an institute that is actually, we are in collaboration in general with Civil and Structural Engineering Consultants. And our resource people are all engineers that are currently practicing in the field. We offer many courses, a lot of software courses, and we also do a lot of workshops for those who are doing their chartered and for anyone that is looking to better their knowledge and to improve their knowledge in structure. So, as I was saying, Structural Design Institute focuses on providing CPD courses and other courses mostly related to structural engineering, but we're looking to expand further as well. So today's webinar is mostly focused on giving everyone not just an introduction to the Colombo Lotus Tower, but also give you all insights to how this monumental structure was designed and constructed. For today's session, we have with us engineer Shirama Fernando from CSE Consultants, who was very actively involved in both the during the course of this project, and he will be providing us with some very interesting insights to how this project came to be what it is today. So without further ado, Engineer Shirama Fernando, I'd like to invite you to take this session.
Thank you, Aisha. So basically, today we will discuss about how we design and construct the Lotus Tower. So initially, I would like to put it on the screen by side. So basically, I would like to give a very we have to thank the people who got us involved in the design and construction of this building. And initially, Mr. Anushka Palpiter, the DG of TRCSL, and also the was the first person who invited us to get involved in this project with the Ministry of Municipal Consultancy. They invited Professor Mendes and Professor Mendes also that made into this project, and we were fortunate to involve in the project from the day one. So this is design and build project by CEIC, and client is TRCSL. The project consultant is architecture faculty Ustam. Is located at Colombo, so it is a beautiful site near the Berele. So if you look at this is this is the north and south, east and west. So this is aligned to the north because this is mainly designed for antenna for telecommunication, and then mainly this building is oriented in the north-south direction because the antenna is directed to the magnetic north. So Colombo Lotus Tower, the client is, as I said, TRCS, from Sri Lanka, and contractor is China National Electronics and Import and Export Corporation. We call it the CEIEC. Consultant Architecture Faculty, Ministry of Manitoba. And this is the contract type is design and build contract. The total construction area is about 30,000 square meters. The total height of the building is 356 meters. So basically, when we started this project, mainly the consultants were Ministry of Manitoba professors. We had about 40 professors in charge of different fields from the Manavadu, from the Nimal in the architectural section, and then we had Professor Dias leading the structural, and Professor Anakara involved in the concrete section. And then we had landscape professors like Professor Shirari Bandana, Balasurya, and then AC Professor who was the head of mechanical engineering, and so many professors were involved. From the industry side, there were chartered engineers, and we were responsible for the civil engineering and structural design part. And I'm the responsible engineer with respect to this town, with respect to structure. So we had a lot of discussion with their counterparts in the initial stage of the project with respect to geotechnical work from the university was involved, structural from the gas, and architecture from the Nimal and also Manavadu. And with respect to project administration, we had from the Sikavadikara involved in the project. So this was a very challenging project to us because it was the tallest building at the time, and then to be designed. And after design, this is the 19th tallest building in the world and tallest in Asia as a tower. So it was very challenging. It's a new experience to the Sri Lankan engineers and contractors. So after this building is built, it will be taller than 300 feet taller than the Eiffel Tower. Sri Lanka, although this is one of the tallest towers, Jetala Stupa, 122 meters tall. It was the second tallest building in the world after Giza pyramids. So tall buildings are not new to us. And also, we are so proud that we had a couple of tall buildings and we were involved in the design of these buildings too in Sri Lanka. So with respect to Lotus Tower, we have four main sections. The Lotus is a flower that architects selected because it is considered as the national flower of our country. So basically, it has four sections in this tower. One is the tower base, tower body, tower house, and the tower mast. So tower base is depicting the throne of the Lotus, while tower house depicting the blossoming lotus. So this is the only tower is open. So most of the towers are like very close. So it is also a challenge to the designers as well as the contractors. So as I said, the tower body, tower base mainly is around 80 meters width, and tower body is to house the lifts, And our house is to house the broadcasting stations, the other facilities like restaurants and and also viewing them. Now, mask is also a major thing that try to try to use for communication purposes. So by doing that, we can eliminate a lot of other towers, small towers, placed everywhere in Colombo. It has become a nuisance to the Colombo and the suburban citizens. The tower base has four levels. Basically, minus 5 meter level, we have on the generators, cooling pumps, refrigerator pumps, and also the kitchen. And ground level, we have the VIP room, the commercial areas, and then the first floor level, first and the second floor level, we have again commercial area, 5 meters and 15 meter level. We have the PV deck, where people can come down to the tower and view the beautiful sight of the area. So tower base, these are some of the data. We have generators, the total capacity of about 2000 kVA generators, 2000 kVA generators, and 500 kVA generators, cooling pumps, refrigerant pumps, cool pumps, so many things. Mainly, the tower house, we have 5 lifts. They are very high speed lifts, 7 meters per second lift. We are up to this now. Earlier, we had only 4.5 meter lifts in the World Trade Center towers. So it is almost double the. And also, there are 2 service lifts where it also has 5 meters per second. And the main challenge is to look at the tower body. It has also depicting the Lotus. The tower house, we have in the 215 meter level, we have the radio and broadcasting rooms. And then 219 meter level, we have the TV transmission rooms. Third and fourth level, we have the banquet halls. Then in the 5th level of the tower house, we have the revolving restaurant. And then we have the 6th level state guest rooms. We have about 6 rooms in that level. And then 244 level, the most popular level, where most of the people now go to 244 level to see the Colombo skyline. And the upper levels, we have the transformers, and then we have cooling towers, water tanks, etc. So, with respect to construction, this was the earlier site where with a lot of rented dwellings, where the government cleared the site and gave these people good houses. Initially, we did 33 boreholes. Some of the boreholes went down to about 40 meters into the rock to find the geology of the rock. So basically, it's a thorough study has been done for the district. So when we did that, we found very solid. The rock is around 15 meters below the ground. And so basically, therefore, because we have the strong very close to the ground, the designers decided to have a rock foundation to support the main tower, and then the podium to support pile foundation embedded into the rock. So it was a very challenging thing because the very lake was very close by. So the contractors proposed us that they have to have a ground curtain around the excavation in order to prevent water coming in. So, and then this is one of the pictures that basically grout is basically it uses this. It's like a cement stabilizer, right? Where you apply grout and mix with the soil, and then the piling was carried out by a local piling contractor and our own piling with respect to the. And these are some of the pile tests that we have done successfully. We done one static load test, one five PDA test, and one file. Every file was tested for integrity. So this is before we do the excavation. There was a dewatering arrangement outside the excavation, and it was connected to pipe networks and delivered to the pump to the bay relay over systems, and then need to stabilize the soil cement is sprayed to the excavation so that we can reduce any collapse to stabilize the excavation. And before we do the excavation to the craft foundation, we use 880 micropiles. Sorry, not micropiles. 800 diameter contiguous piles around the craft, and these are some of the grout piles is used to block water to coming through the. And after that, we again have a grout curtain behind the. So this is the raft foundation, where it's around 3.5 meters thick, sitting on the raft. So in order to excavate, here we have this grout pipe. So here this is because the cylinder you don't need any cross bracing, so you only have this tension ring, because it is all in compression. So this beam is in compression, and everything is in compression. So you can easily dig without any cross bracing because of the shape of the stem. So when we dig, this is the first time I saw the rock. Generally, we always estimate the rock depth and also imagine what is the rock type. When we dig, then we find a lot of fractures, the weak rock, and these rocks has to be strengthened using dowels and concrete to to see this is the foundation. So this is what you see the vela beams, contiguous piles, capping beams, and it's a very good experience for us. And mind you, this is below 15 meters next to the building. The next challenge was how to now the concrete is very thick. Heat of hydration is one of the questions that we need to tackle, and the maximum temperature that we were trying to peak hydration temperature that we wanted to have is less than 70 degrees. So the proposed grade of concrete for the up was around 40 C40, and then we need to control the OPC content in the mix to reduce the temperature, and also we need to control the water, what's the water binder ratio to around 0.4 to have the strength. So both were very challenging, and after doing a couple of trials, we found this mix, and then we boiled down to one mix, and the trials have been done to check whether that mix will give satisfactory results with respect to strength as well as the peak hydration temperature. So one way to do is to reduce the temperature is to reduce the initial temperature, and to do that, the main thing is the main component of the concrete is aggregates. So cooling aggregate is one of the ways that we can reduce the initial temperature. So flake ice was used to cool the aggregates, and finally we achieved our goals with that, and then proceed with the concrete. You can see it is very close to peak hydration temperature is very much close to 70. And PPC concrete, that is with 25% fly ash blended cement, is used to go this. So after that, we also use waterproofing to protect the concrete from water coming into the basements. So membrane type waterproofing was used in the basement. So we had for steel, we use about 400 tons of steel for the foundation, and the total amount of concrete is around 4,000 meter cubes.
The question from the audience: is the excavation covered by a system of secant piles?
It is not secant pile; it's contiguous pile. Contiguous piles. There is another ground pile behind the pile to make sure that the water doesn't come to the contiguous pile. Actually, we didn't have any problems with this. So basically 4,000 meter cubes, no concrete supplier can supply. So we tried to get 5 suppliers, including our contractors, EIPC, and Maga, Sunken, and City Concrete, and also Intermix Concrete, which was at the next door to the site, was used to. So we have to maintain the same mix. Sometimes because some of the trucks are away, we might need to change the admixtures so that we have a more retention time. And the total concrete we use we poured the whole thing within 36 hours. So not a single concrete manufacturer can hold all the materials at one time. So we had to plan on. So we are the people count, the concrete suppliers come, and all this was meticulously planned, and we select a particular day, that is, I can remember 8 August. August. 8 is a very good number for the Chinese, and they started this concreting, and then that was a Hajj, Muslim holiday, and we closed that DRB and they started 8 o'clock in the night. Everything went. We had a lot of about 20 postgraduate graduate students we used from Colombo University to monitor the trucks, the slum, etc. So there was like I put two, the students. Sometimes they are more enthusiastic. I was afraid that one will fall into this thing, and I had a chat with the students that if you finish this project successfully, you will be part of the history. Otherwise, you will be part of the structure. So everybody was warned, and then the seniors were appointed to look after these graduates, and they did a wonderful job. There are many more stories to tell. I cannot tell the public. So this is a live. So you can see Professor Dias and the two experts that we had to concrete was there during the pouring time, even in the night. And this may be, I think, around 12 o'clock. And you can also see so many trucks lining. Some are concrete trucks, some are cement trucks, some are cement bouncers, some are sand lining. One person told me it went up to the California Bridge. So such a big operation, and we are pleased to be part of the. So many people. I think there's a video we can play. So many people was like involved in this. In the morning, we cannot make sure that it is very there won't be a big thermal shock into that. So we put the polythene, put sand on top of it to keep the temperature at a particular level so that it won't get up. And Professor Dias in the morning, after doing all this, has come in the morning to check the temperature. So that is the kind of enthusiasm process that.
One question. They said, sir, were there any sort of mineral admixtures used for the concrete to ensure the osmotic effect within the concrete?
Yes, fly ash was used, that is 25% of fly ash we use, so that it will reduce the initial heat gain because OPC is less, so it's a secondary answer. So that is why we use phosphate material like fly ash. Thank you for that question. So basically, after that, we started building the base. The bottom part of the base is around 1.8, 1.2 meters, and then it reduced down to around 600. We had 3 floors, and this is what you see is the waterproofing of the bottom base, concrete ring beam, the outer ring of the tower, and also protection. And then you can see there are three rings. One is the this is the power base. The ring there are this is the outer ring, inner ring, and the middle ring. So outer ring is around 600 millimeters, and these are some of the during the lower level of the tower we use traditional formwork, and it was here you also can see basically now this is a very large 80 meters. So these are some of the core strips that we have kept in order to avoid shrinkage cracks, as well as this is basically now tower is going up to 265 meters. So if we join this tower with the podium, then there will be a crack because of the differential shortening of the towers or axial joint. So we keep this joint posted, and we join this after 75 meters after building the tower and monitor the deflections of the column and the slabs. And these post strips are kept because in order to avoid the shrinkage. You can see the post strips. So after we completed you can see the quality of concrete. We use concrete, very high flow concrete, which has a flow of around 400 to 500. And most of the people think when there's a myth that in Sri Lanka that Chinese construction is bad or not good. So actually, I have worked with these Chinese contractors for the last 15, 16 years. I see their technology is very high, and also their quality of work is very good. So you can, as I said earlier, we had three rings. One is the outer wall, inner wall, and the lift wall. So outer wall was around 600 to the top. Inner wall is around 350 to 400, and lift wall was around 200, not 200, 300. So this is the arrangement in the tower body. You can see the high speed lifts, and then you can see the service lift here, and this is the fire staircase. So very narrow. So the diameter of the tower body average is around 15 meters. So very slender. 600, 350, 300. So tower body, you can see different shapes like a lotus. So it's very difficult with respect to the formwork. You can see so because every time you go up to 75 meters, the body shape changes, and also the architect wanted this frills of the lotus, and it took a lot of time and also a lot of energy to contractor. So, and also lifting this is this thing we use a climbing formwork. So these all automatically done. It was also a very new experience for as a Sri Lankan engineers, and now a lot of Sri Lankan contractors use this jumping forward. And mainly to expedite the work, we also contributed. We discussed with the contractors. The time was a critical thing, and then we told them that we can prefabricate the steel cages and lifting, because we had done. I have done this for the celestial residents. So we use so initially they were not agreeable, but later on they found this is much easier, and they did that. So most of the cages are being fabricated down and then lifted up. So this is one of the inputs that and these are some of the formwork systems you can see here, especially at these areas. You can see that triangular thing, and you have to change that every up to level 75. So this is these are some of the stages of construction. This is the politically level project where every stage is a political development. And we also enjoy a lot of TV.
There's a question someone has just asked. What is the waterproof material used for the outer perimeter of the base?
We use torch on membrane. So basically, pumping concrete at a higher level is very important. Where you cannot use a normal concrete to pump up to 265. And it is also an experience for us at that time. So self-compacting concrete is one of the new type of material that we use. So basically, it is like flowing very smoothly, and also it doesn't segregate or no bleeding. You look at the edges, you don't find any water. So basically, this is the mix, C50 mix that we use. Here you can see the maximum cement, that is the binder with 25% binder, and then the water binder ratio was around 0.33. And when we go up, we have to increase the cement content, and also but by keeping this visible, otherwise you can see the water and increase here. So water cement ratio we cannot change because of the strength. So when you go up, we have to use like after 45 meters, we have to use finer aggregates, finer coarse aggregates, and also the coarse to fine ratio also reduces when you go up. And when you and also when we go above, we also use additional additive like pyrite to make the flow thinner. So you cannot use the same mix at different levels. So when you go up, we have to change the mix. Strength is the same, but to pump, you need to change the coarse to fine ratio, as well as we have to add additives to increase the flow. This is the mix for grade 40 and 345 concrete. So similar approach. after 75 meters, we have sand. So basically, you can see here the size of the hole is very small. That is around 350. Then the post to pile ratio has to form cloud to right one. Right. So basically, a cell compact. So, and also another issue is when you pump, you also gain temperature. You gain temperature due to pumping, and then the slump will. So there is a water cooling water bath which passes through that in order to cool the concrete. And this is brought to this thing using a robotic arm. You can see it is also climbing with the yeah, I mean that yeah, you can see that the concrete is moving very smoothly, right? We used to put 5 meters per foot with little vibration, not lot of vibration. Okay. So basically, it is like every 5 days, every day we put a 1 meter. So that is the kind of rate that we know. And the other issue that mainly worried me was the survey part. Whether this tower become tilt. So mainly, I was really focused on that. Basically, with respect to the initial surveying monuments to the day-to-day survey. We had 3 teams. One is the contractors team. We had our own independent team, and also after every 10 floors, we have an independent survey checking the lift floors. The main problem is the tolerance given by the lift manufacturer was 50 millimeters for this. So if the lift we don't get the time, the lift will not go in, right? And then that is also a scary thing that I want to add. The other thing is when we go up, we are the tallest, and then the other buildings are tiny. We don't have line of sight, so we cannot have. We have to have our positions intact. The third problem was this tower is very slender. It moves due to wind, moves due to temperature. So therefore, we have to think out of the box how to do it. So as the principal of that team, I told we need 3 methods. One is this total stations that we normally do. The second is laser. Other one is GPS. So all 3 methods were used to locate a particular point. Okay. If all 3 goes wrong, then I have excuse. So basically, every method has their accuracy. Okay. Somehow, after we doing the whole exercise, the maximum deviation may be around 25 minutes. I think for this kind of tower, it's a very good. So you can see the laser method machines, the total stations. They say the problem is after 100 meters, the laser bulb it's very big. The move accuracy. So you have to move down. And also the total station. So you also we had three relatively tall buildings, which is not also is not moving as our reference points. And then we used to do these, and there were here. What you see is the GPS machine, and we had a couple of lasers, prisms fixed to these, so people can see and get the locations. So there are 3 methods of at least 2 methods to check.
Few questions. So one is it required to use vibration on self-effective concrete?
Vibration, it's like this, it's a 5 meter this thing. So self-compacting concrete, because we are doing 5 meters, there can be trapped air inside. So it's better to get it out. So that is why we need that.
The next one is, what are the precautions that we should take to make it resistant against winds, cyclones, as Sri Lanka is very close to the ocean?
We will be discussing that.
Then the next one is, what was the size of tolerance that was maintained in the project when it came to the design coordinates and the coordinates set out at site when it came to piling setting?
Piling setting out is not a major issue. Basically, tolerance because pile can actually we even move several millimeters, we accept. Right. So it is not a major issue. The verticality wise, it is 1%. But generally, the building wise, we have to treat this as a monument. So, with respect to the accuracy of the survey, it should be around 1 into 20,000. So this is a different kind of contract. So I hope I answered. Right. So let's. So we had an in-house testing laboratories to control the quality of it. So this is a very important. It is a good thing that every steel, concrete, everything will be quality. Another thing is, now this cover, when we analyze, it is as now this is a very large thing. So contractors were very worried about cracks generating. So post tension slabs with unwanted post tension wires. And then also the tower, also we the post tension compression, that is called pre-compression, because when we analyze in a cyclonic situation where you get about 2 Newton per millimeter tension in the tower. So therefore we decompress around that amount in the tower, so that it will never go to tension during the so there are also additional tension pre-compressing using post tension work for the tower mass, and also circular pre-stress post tensioning in the tower house. This is the post tensioning work at with unbonded post tensioning steel wires at the tower base. These are the post tension ducts at tower. car body. And this is the post station that at 250 meters away in the tower house. These are the post station that for the tower house. When you come to tower house, it is made out of steel and glass. So that is the practical way we can do it. So up to here, you get concrete, and then you start the steel. Then it is expanded. Here we get 15 meters. The diameter of the tower house goes up to maximum of 36 meters. So you have to, and then we have to have this glass facade. So most of the tower house work was prefabricated, including the steel staircase and also the steel. The tower house construction was very critical. Say, for instance, we have to build all this in the air. So first, we put this steel, the concrete pan, and then we install the platforms to construct the field works. So this is the platform installation. You can see it's very good, right? So and Chinese workers were very efficient and also very knowledgeable. And they knew exactly what to do. This is a kind of experience.
So is the power plant located in the core?
No, it is outside. So this is the platform to build the field wall. And also, these are some of the anchors that is going to was used to place initially when you are completing you to place all this so that we have to receive the steel members. This is the wall. You got the floor. You can see. They are all painted because corrosion is another. Some are painted gold. You can see it's an assembly, prefabricated assembly coming. Yeah, whole thing. The steel construction. Very skilled worker, you can see when they transport 3 members together to make the train efficient. With a lot of things that we can learn from this Chinese work. So this is after completion. And then we need to fireproofing one of the things. This is the cementitious fireproofing used for the beams. Yeah. Very. Then the discussion is on the curtain walls, so which is the most interesting part which we can see now. Yeah, we had two types of curtain walls. One is in the tower base. We have sticky type curtain walls where you have the frame and then glass is being fixed to that, and then this is the typical sticky type. First, the aluminum frame is anchored to the building, and then glass is fixed to the using. And the tower house is the glass construction was very difficult. We had a lot of drawings to understand the construction, and then the unitized panel system was used to that means you make all the panels below, or actually imported from China, and then it's so basically what you have is there are receivers and then set fixed to this hook to the these panels. This is the aluminum panel. Similarly, they use the glass panel. So this is computer together. Then the Lotus Tower mast. Mast is another thing that we had a big challenge. The major last part of the structures. So the total height of the mast is 94 meters. Steel section is 66 meters. Totally around 80 tons. So you can see different shapes at different levels. Below we have 2 meter by 2 meter section, and you have a what do you call it? Octagonal section, then the rectangle section, and circular section. The reason for that is this is how the tower mass we thought of raising. So there were a lot of ideas by the contractors. Finally, we thought this is the safest method to take it to the port, and using technique different. So every 6 meter section was that and taken out. So the bottom this part is concrete. Okay, that is to receive it. So basically, this is how the steel mask is installed. These are the 4 jacks that have been used to. The jacks are moved very slow. Uniformly. Otherwise, it will. And it welded section by section. Mainly in it's a 40 millimeter thick base. So basically, the weld there are 4 welders welding at the same time, and you cannot just stop. So first you have a lot of processes: preheating, then you start welding, and then again post heating, etc. etc. So much of initially we had to pre-qualify. So the temperatures are also important. Then you have to do a UV test, that is ultra sonic test in order to find the cracks. So if there are cracks, you have to again read it. So there is an independent party checking that. So this is zinc frame. This is the mask is galvanized. So this area will you closed, and then you need to redo the zinc spray. And this is the first time I've seen a zinc spray. These are the 4 jacks that discuss the mask. So these are. So with time you saw it coming up slowly. And I kept one engineer full time just to watch this thing and make sure there are no. This is me finding the mask. So let's look at the design side. I think if you have any questions with the construction, we can. So, with respect to the superstructure design,
Says, what's the steel grade used for the angle columns and its associated beams?
that is 355 was the steel grade that we use for the.
And I think they could maybe give us fire proofing that was done for the steel. I think it was when it's framing.
Yeah, fireproofing is cementitious. There are intermittent paints like thin coatings. This is a thick coating. So this is a cementitious base fireproofing. There are many fireproofing thick coating based on monocle line, etc. So superstructure design. We looked at the model analysis, gravitational analysis, lateral load analysis, wind, earthquake. There was a question with respect to wind, earthquake, and static analysis, dynamic analysis. With respect to earthquake, the static and dynamic response spectrum analysis, and also axial shortening, also temperature analysis, also fatigue analysis we did for the mask. because master is, can fail in fatigue. So we got Professor Holmes, one of the best in the world, from Australia University. Also, this is the person who got him down to do this test, do this and calculation and explain to the client. And so we did our best to with respect to the handle itself. So this is one of our models done in tabs. And when you do that, the fire is another thing that mainly because of the same one before, which I will discuss. So you can see here the periods are in the range of 3.9 seconds. And you also can see the X and Y periods are very much similar because they're symmetrical. And the third and fourth is 1.5. Any guess? What is this period? This is the tower mass speed. Okay. So, and also this is the wind climate studies done. Most of them were done by our company, and also some of the we got it from the meteorology department and also from the Colombo airport. So this is the simulation studies done by the Mendes State, Dr. Dami Panda, doing the work, where you can see you can see this has a different period and the tower has a different period. So this is what was observed in the earlier slide. Yeah. So tower will fail, will not fail effective. Here, these are some of the millimeters that we monitor the movement of the distance. So basically, in a very windy days, the lift cannot move, so they have to stop because it is moving. So lifts, there is a the lift. There is a controller. Yeah, when the wind speeds are high, automatically the lift will come down. So it can sense and then we call it sway control or something like that. So basically, this has been thoroughly studied with respect to wind. Especially, this is we did with our study. We have a rigid body, and these are the profiles to take the wind profile. So you have a lot of transducers to check the pressure, and then this is a elastic model. Yeah, it moves with the it represents the stiffness of the. So this is a rigid body. So it only have sense the pressures, and then it will the internal people will interpret that and give us the results. And here we have the elastic model, where elastic model, where you have the stiffness represents. So you can accurately get the acceleration. So basically, in the tall building, top story acceleration is a major issue. If the top story acceleration is more than 20 milli, then you can feel the motion. So you have feel the motion every day, then it's sick. Right? So here, realistic model is one other thing. Another thing is we did a special study for the our house metals. It's a rigid body study to find the pressure, because it's very difficult to find mathematically the pressures in the, and this is the wind tunnel that we use in China. This is the wind tunnel that we use to. It's a very long wind tunnel. Right? A particular chamber we put this in, and this rotates, and you can get every 15 degrees you can get the pressure. But actually, this is a circular building. There are no big buildings around. Therefore, this issues. You can see that the pressure diagrams given by the entire people. The pressures are in the range of 5 meters per minute. Very large pressure. So, with respect to the wind tunnel results, so these are some of the theoretical ones. Wind tunnel results. In a cyclonic day, deformation is around in the antenna can be around 300.4 millimeters. At this kind of a wind pressure, it can go up to 500. So basically, for the antenna, the maximum allowable deformation that is 40 to 100. For the building, it shows 600. So with the wind tunnel, they prove that this is within the allowable limits. So basically, you can see this is allowable. Sometimes for buildings we use HO 500 or HO 400 also. So you can see some of the tension that we observe in the building. So this is in the range of 5 to 6 meters per minute. Under service. Models I have seen, they use like similar models like for the buildings. When the architects make they use similar models for the rigid. In the other one, they have steel members connecting different sections, so that it will represent the stiffness of that. So it will move. So basically, with respect, I told you several sections. Now, most of the buildings are moving, and also you can see that these chimneys move due to wind. Okay. So what happens is, with time it will fail in fatigue. So this was a major problem that we had in. It will not fail in the higher the maximum wind. It will fail in a lower wind speed, right? So fatigue failure is very common. So basically, now when the wind passes, there is a phenomenon called vortex shedding, where wind attach and detach. It doesn't happen at the same frequency. It has a small time lag, about 2 seconds. Okay. So because of that, it can have along, it can move in the lateral direction. Although there is a along in wind, but it can move in the lateral direction. So it's called crosswind. So if the crosswind or water shedding frequency matches the frequency of the structure, it will resonate at 4. So because of that only, they have designed the sections at different level, sections at different scales. So the total antenna doesn't have the same frequency at different levels. So when the wave passes here, you will have a different shedding frequency. Here, shedding frequency, it will never in line like a circular thing. So we confuse the wind. So this is the reason. So after that also we did a study and see what is the kind of wind speed that will affect the tower. So what we found is at a lower wind speed, this can fail. So we made sure that we actually increase the thickness of the steel. Generally, fatigue stress is about 1/3 of the lava stress is 1/3 of the steel stress. Earthquakes. Earthquakes generally in our part of the is very deep, very low. So basically, earthquakes occur in the plate boundaries. So we are inside the plate. So very unlikely that there is a, but there are occurrences in Sydney and Newcastle. There you can have interplate type earthquake. Interplate. So a plate, there may be flow upon in the plate, and it can be. So earlier Australians also didn't what about, and now after the Newcastle earthquake, then they started looking at it, and then they have very good earthquake force. So since we are also in the same way, and also because Mendes was involved in the project, and we also use Australian force to look at the risk in our country. And this is what I believe is, if the epicenter of the earthquake is more than 500 kilometers, we will not get any major disasters in our country. So most of the time there is a called diffuse phase bound area. It's almost about 2,000 kilometers away from our planet. And then these are luckily for us, they are going away. Diffuse phase. So if it is coming inside only, there's a problem. But we can get but we may see now even now say for Sumatra, we got like a 9.4 earthquake, but we didn't even feel that we got hit by tsunami. So you don't have to worry much about earthquakes. But there have been reports that Colombo had in the report by a priest, a Portugal priest, written in 1615, that there had been an earthquake very close to Colombo. And so then also in 1939, there had been an earthquake. So geologists predict that earthquakes can occur very close to Colombo, and these are very in the range of 4 to 5 in the Richter scale. So most of the work has been done by Professor Abeko of Sri Lankan University. So these are even the reason so this is because most of the time there's a failed manner are shown this is by the geologists. Yeah, it is a place where two or four they are filled with sediments. So it can give rise to a earthquake. This is the 16.2 very close to Colombo, and as report it says that 2,000 people have died. So these things repeat. The tsunami, 400 years ago. 2016, 15, 400 years, 2015. So these things repeat. So we have to be very deep. We had been designing buildings for earthquakes from 1990s. And social structure engineers has given guidance to the engineers how to detail it. And people are aware, and most of the people do this. So I think actually, because Mendes plays a major role in introducing earthquake design to Sri Lanka. I can remember he coming and speaking to us in 1996, and then people after that only all this awareness came in. And what happens in the earthquake when the ground moves and the buildings also has different periods. Generally, every building moves, including this building. So generally the period of a building is around 1/10 of the floor, number of floors. If you have a 50-story building, the building period should be close to 5 seconds. So what we normally do, so you put a and then you can see the maximum deflection of a particular time. And then you plot this displacement curve. This is called then if you integrate by 2 times, you get the acceleration. So it looks like this. Right? So basically, so this is the peak ground acceleration, and within couple of it goes to here, and then it dies down. Generally, earthquake lasts for around 30 seconds. Within the first 4 seconds is the ground. If you can survive for the first 4 seconds, that means a 40-story building. This is our period is 7 seconds, 7 point something. At that time, we get a very low acceleration. Right? So these some of the things actually initially developed by the Chinese design for the Colombo Lotus Tower, and we tried to evaluate them. And then later, the Beradini University professors and the academics developed a response spectrum, which is very close to it. And so these are some of the issues and these response spectrums have been used for the building design. And actually, this kind of building basically earthquake is not the major force in the design building. Wind is the main in this particular building, because we are a very low seismic. So,
Question. This is regards to meaning. Sir, were there any other precautions apart from changing the width and regular intervals in the cover mast against water shedding?
now, we wanted to increase damping by putting a chain. Actually, Professor Mendes was pushing for that because he has done that before. But since we could not prove that before, well, after doing further study, we didn't put that chain. So otherwise you can put a chain to dam. That is one of the things. But we did it. So fire studies are mainly done by Professor Mendes' team in Melbourne unit. Professor Dr. K. Where they simulated the fire behavior, people's behavior during a fire, because about 3,000 people can stay in the tower in a particular time. So this was a good study and vertical also. So this may be the first kind of thing that we have done in the world. So basically, in order to evacuate 300 people, so with the total exit, we can achieve it about 60 minutes. So this study was done. And also the other worry was the impact. Very close to the tower, every February 4th, we have this aircraft flying for the independence. So it was a big issue that we need to consider. This cannot be. So we wanted to see what happens, because our house is made out of steel, and if one member removes, what is going to happen when the total building will collapse? During I had the chance to observe the plane moving very close to the wings, moving very close to the tower from prime ground, and we have some photographs and the videos. So it's a bit of a scary thing. And then we remove one of the key elements, and we found only a small area is going to. Therefore, there is no major issue with that. And the other thing is yes.
There are two standard questions. One is, what is the design PGA value for the use for the earthquake design?
So it's a very straightforward question, and the straightforward answer is 0.08 G.
Second question is, what is the highest magnitude of earthquake which Lotus Tower can bear?
Generally, we don't do argument studies with respect to earthquakes. So we normally don't do that kind of thing. We normally do is basically what are the possible risks, and then whether that possible risk we have to check for 50-year return period, and then we have a performance criteria. So 50-year return period, there won't be any damage. If it is a 500-year return earthquake, there is a possibility of having small damage, especially in the before we call it a couple leaves. And then if it is a 2,500-year earthquake, it will not collapse. So my great grandchildren also be able to see. Like if you look at the stupas standing 3,000 years. So you don't have to worry, that has not happened. Right. So here we are trying to see now most of the time EV forces are there in the more than the natural forces. EV forces, the fire is one. Other one is the people. So generally, they want to make a statement. They won't make a statement in a smaller building. They will make a statement in the high one. So basically, when we design, we have to think about this things. So generally, we will look at blast. Blast is force due to chemicals, and it lasts for milliseconds. So if we can survive that millisecond, if our key elements can survive, the building won't collapse. Right? Getting people getting hurt and all, it's a different. Right? So building wise, it's not different. So how to? There are two strategies. One is make sure you don't allow vehicles, the charge coming to the building, very close to the building, standard distance. So generally, with my experience, the 30-meter standard distance is the best way to avoid building. Like let's say you get a TNT, we have also within my career, and we have seen central bank bombing. One ton of bombing came into the central bank. So it should not be able to come very close. If you have a 30-meter standard distance, you are safe. Building safe. Okay. So basically, that is one of the strategies. The good thing about Lotus Tower is it's far away from the road and not easy to come inside. And we have to make sure that the unloading, even unloading loading vehicles, which can come very close. We have a 80-meter podium, 40-meter radius. So it is also not close to the tower. So this is also good for that. But there's a possibility a person can go to the tower house with a 10 kilogram. So we have to assess the threat. And then generally the pressure initially is a positive pressure. And then you get a negative pressure. Most of the time, the glasses will fall out to the side. So we have to look at what kind of threat we have, and then we try to simulate what will happen to the structure if threat goes to very close to a element. So we found there's not the major element will not destroy because of a possible threat in the Lotus Tower. So that is also one of the work that we have. So when you go up, you will see a beautiful view. Those days only we could now all the people can in the night, it's the most beautiful vision in the skyline of Colombo. And every photo that now you have has a background thing, even the news photos, everything. So actually, Lotus Tower defines Sri Lanka, like Eiffel Tower defines Colombo. Eiffel Tower defines France. So when you say France, the only first thing that you remember is that is what the importance of this building. Iconic buildings defines places and in fact people. So these are the buildings that more people, more than 7,000, 8,000 people visit daily basis to the town. Locals, foreigners. So it's amazing. And now we have repurposed the tower as the epicenter of technology, and you will see a lot of robots and technology displayed in the tower. People and gaming areas, so many entertainment in the tower, so that you will be very happy to see A lot of people criticize this tower. That is the same thing that happened in Eiffel Tower. At that time, the Eiffel was taken to courts for wasting money. Now France is surviving. So this is a tower that happened to. It's a good thing because a lot of engineers went through, a lot of students went through this, and total technology, there's huge technology transfer in our industry. Almost all the top contractors was upgraded their equipment and our industry went to a very big height. And most of the other towers, buildings were done by our own contractors because of this time. So a lot of people miss this motion because they think this is a political agenda and because they are prejudiced by the kind of talk. But actually, this tower has given to the country the hope and also pride of the people. Pride is the most important thing. Since more than very important than food. With respect to sustainable features, all the equipment with respect to lifts, generators, and also the cooling towers, which consume a lot of energy, the designers consider the most energy efficient system, including the escalators. So basically, operational energy, in fact, we have looked at. So this is one of the good sides from our photographs. In the background of this tower. Thank you. Yeah, now we can do it for. We have to again see where when you design something, we have to see what is the most critical element. So we don't need to run total process. We only look at where the critical element, the key element, and then we see what happens to the element when that incident happens. Otherwise, you always impact. I don't think nothing will happen because basically it's confined. It is less damaged.
Are there any other questions from the audience? You can send your questions on the chat. Also, the Google form is now active. You'll find the link on the video description. So please make sure to fill the Google form if you want to receive your certificates. The form will be open for around 20 minutes. So you'll have time to fill it. If there are any questions, please do send it on the chat. We are monitoring it and you can always ask your questions. Thank you everyone for joining today's session. So as I said, the Google form is now active. So please make sure to fill it. It's there in the video description. Please click the option that says more under the description and then you will see it. Do stay tuned and please do keep an eye on our WhatsApp group because we will be updating it with details on our upcoming courses and on upcoming webinars. So we do try to have a free webinar every month to give you all the opportunity to learn from some of the best engineers in this country. And I hope it was quite evident that the engineers that we do have running our courses, Mr. Engineer Shiramal is one of them. They are all people that have been involved in these projects. They have hands-on experience in these projects, and it is that knowledge that they share. So do keep an eye because towards the end of this year, we will be having another high-rise course, which will be looking into these details a lot further. It is an assignment course, and we got some very good responses from the participants that took part in the previous session that we had in the beginning of this year. So if you're interested in learning more and in enhancing your skills as an engineer, please do keep an eye because we will be advertising the details for this course in due time. We do have other software courses as well, so that you all can up your skills even in that aspect. So thank you very much for joining us today, and we will see you in the next session or in the next course. Thank you.